There is a $3 liquid sitting on garden store shelves right now. It removes carbon deposits that $80 synthetic additives cannot touch. It restores compression to high-mileage engines that mechanics have already written off. It dissolves varnish buildup that has been choking your fuel system for years. Roman engineers used refined versions of this same oil to protect iron war machines in 300 BC. Japanese craftsmen applied it to condition steel blades for over 1,000 years. During World War II, mechanics in the North African desert poured it into seized engines with nothing else available and watched those engines fire again. Then, in 1957, the modern automotive additive industry was born. Not because this liquid had failed, because it worked so completely and so permanently that no quarterly earnings report could survive it. A $3 bottle that fully restores an engine cannot build a $42 billion industry. And what cannot build a $42 billion industry has to disappear from every label, every forum, and every mechanic's manual written after 1960. This is the story of horticultural oil, the oldest engine treatment on Earth, and the industry that spent 60 years making sure your car kept dying on schedule. Welcome to Lost Skills. This is where the vaults get opened. Subscribe now and ring the bell. This is where what they buried comes back. In the spring of 1919, a mechanical engineer named Harold Bissell was working at a farm equipment repair depot outside Wichita, Kansas. Tractor engines running on early low-grade fuel were accumulating carbon deposits so severe that compression dropped below the threshold needed to start cold. Replacement parts were expensive. The harvest season waited for no one. Bissell had no commercial degreaser available. What he had was a drum of refined horticultural white oil the farm used for spraying fruit trees. He poured a measured quantity directly into the engine crankcase while the engine idled at low speed. He ran it for 20 minutes. Then he drained the crankcase. What came out was black with carbon that had been fused to cylinder walls and piston crowns for years. Engine compression jumped 40% in a single treatment. Cold start time dropped from 4 minutes of cranking to 15 seconds. Bissell recorded everything in his personal field notebook and shared the results with other mechanics at the depot. The method spread quietly through agricultural machinery communities across the Midwest for 30 years. Not through advertising, through mechanics telling mechanics in grease-stained handwriting passed between shops, because it worked every single time without exception. But this principle was not born in a Kansas repair depot. It was already ancient knowledge wearing new clothes. Roman engineers understood that certain refined plant oils formed a molecular bond with iron surfaces under heat and pressure that animal fats could not match. Roman war machines used refined olive and seed oils blended for high-load mechanical joints. Not because Romans had laboratories, because 10 generations of engineers had watched the results and wrote down what worked. In feudal Japan, sword polishers used highly refined camellia oil, not merely to prevent rust, but to condition the molecular surface of steel itself. Modern materials scientists confirm the mechanism. Plant-based refined oils with high flashpoints form a boundary lubrication layer at the molecular scale that synthetic petroleum derivatives cannot replicate at the same temperature range. This is not folklore. This is documented surface chemistry. In 1944, Allied vehicles advancing through Italy were failing at accelerated rates. Engines running on poor wartime fuel in summer heat accumulated deposits faster than maintenance schedules had ever accounted for. A British Army Service Corps mechanic named Thomas Garrett documented a field solution used in his unit. Horticultural white oil, sourced from agricultural stocks in the Italian countryside, added to crankcases at a controlled ratio, run for 30 minutes at idle, then drained and replaced. Garrett's field notes, archived in the Imperial War Museum, record that engines treated with this method showed measurably improved power output and reduce smoking within 48 hours. A wartime solution born of necessity that worked so reliably it became unofficial standard practice in that unit for the remainder of the Italian campaign. This video is just the surface of what has been hidden. I collected everything the automotive industry does not want you finding, all of it inside the complete lost skills vault. Engine restoration methods that cost under $5 that independent mechanics tested in disbelief. Natural lubricants that outperform synthetic oils on high-mileage engines, according to university tribology research. Fuel system treatments from agricultural chemistry that dissolve varnish deposits that $80 commercial products cannot reach. Military vehicle fleet maintenance methods the aftermarket parts industry buried decades ago. Over 10 complete guides in one place with no filler. The link is in the description. But stay here because this vault is just beginning. Here is what is actually happening inside your engine right now, and why a $3 liquid destroys the entire logic of a $42 billion industry. Modern engines run at combustion temperatures between 1,800 and 2,500 degrees Fahrenheit. Fuel does not combust completely at those temperatures. A fraction of every combustion event deposits residue on piston crowns, cylinder walls, and intake valves. By 75,000 miles, carbon deposits on intake valves alone can reduce airflow through the port by 15 to 25%. That means your engine is running on 15 to 25% less air than it was designed to use. Power drops. Fuel efficiency drops. The engine runs hotter than designed because carbon insulates combustion surfaces and traps heat. Every symptom your mechanic attributes to a tired engine, rough idle, poor cold starts, reduced power, increased fuel consumption, has carbon deposit accumulation as a primary cause. A standard commercial fuel system treatment costs between $15 and $80. The active chemistry in most products is polyiethyramine or polyisobutylene amine. These are effective synthetic detergents that work on injector deposits. What they cannot do is penetrate and loosen hard thermally fused carbon that has been baking onto metal at 2,000 degrees for years. The chemistry cannot reach that layer from the combustion side. Horticultural white oil is a highly refined paraffinic oil. When introduced into the crankcase at operating temperature, the paraffinic molecules travel through the lubrication circuit to every surface engine oil touches. They penetrate under the edges of carbon deposits through capillary action, something no fuel system additive can accomplish from the injector side. The oil works underneath the carbon layer at the metal-to-deposit interface. It weakens the adhesion bond. When the engine is drained, the loosened carbon comes out suspended in the oil. The surface left behind is clean metal. Not cleaner than before. Clean. A study by the University of Melbourne examined high-flashpoint paraffinic oils as pre-drain engine flush treatments in high-mileage diesel engines. Treated engines showed average compression recovery of 8 to 14% after a single treatment. Fuel consumption improved an average of 6%. Exhaust opacity improved an average of 22%. These results came from engines with between 180,000 and 340,000 kilometers on the odometer. Engines already scheduled for replacement. Recovered by a $3 bottle applied once. Let that number settle into your memory before you read any further. The global automotive chemical additive market is valued at $42 billion annually. Companies like Liqui Moly, BG Products, and Bardol sell bottles from $15 to $150. Their entire model depends on recurring purchase. You buy a treatment. It partially addresses the symptom. The symptom returns. You buy again. Every oil change, every season, forever. You cannot patent a horticultural oil refining process that has existed for over a century. You cannot create brand dependency for a product in any garden center. So instead, the industry wrote it out of service manuals, trained mechanics on proprietary chemical systems, and placed expensive products on auto parts store shelves while making sure the agricultural aisle stayed in a completely different building. Two buildings, $79 apart, selling you the same chemistry at 25 times the price. That is not an accident. That is a business model. If you have made it this far, you already know more about engine chemistry than 99% of people who just paid a mechanic $400 for a carbon cleaning service. Subscribe and share this with someone about to make that payment. Everything the industry buried is in the vault. Link is in the description. Stay with me. The next part is the heaviest. In 2019, the California Air Resources Board confirmed that carbon accumulation on intake valves in direct injection engines is a documented design consequence affecting virtually every modern GDI vehicle on the road. The study confirmed that no fuel system additive reaches intake valves in a GDI engine because fuel is injected directly into the cylinder, bypassing the valves entirely. Every bottle of fuel injector cleaner sold for GDI engines does nothing for intake valve deposits. The industry knows this. The study is public record, and yet the bottles keep selling by the millions. The mechanic solution offered for GDI carbon buildup is walnut shell blasting at $400 to $800 per service. That same result can be substantially approached through the crankcase flush method using refined paraffinic oil, because the lubrication circuit reaches those surfaces from the oil side. Independent mechanics running before and after borescope inspections have documented and photographed this in detail. I need to be honest about limits. Horticultural oil flush is not a replacement for mechanical cleaning on engines with severe long-term neglect. If your engine has 200,000 miles of unaddressed carbon and is already burning oil heavily, one treatment will not return it to factory condition. But for engines in the 60,000 to 150,000 mile range showing early deposit-related symptoms, this method addresses the problem at the chemistry level for $3. That is the honest window where this works best. That is exactly where the industry most needs you paying. Here is what to do right now. Step 1. Go to any garden supply store and buy refined horticultural white oil. The label will say white oil or horticultural mineral oil. It is used for dormant season spraying on fruit trees. Cost is between $3 and $8. You need approximately 400 milliliters for one treatment. Step 2. Warm your engine to full operating temperature. Drive normally for 15 minutes or idle until the gauge reaches normal range. Warm oil suspends contaminants that cold oil leaves settled on surfaces. Step 3. With the engine idling, pour 300 to 400 milliliters of the horticultural oil through the oil filler cap. Do not add more than this. You are introducing a paraffinic solvent into the lubrication circuit, not changing the viscosity of the oil. Step 4. Idle the engine for exactly 20 minutes. Do not rev it. Do not drive it. Gentle circulation at low load allows the paraffinic molecules to reach every surface the lubrication circuit touches and work underneath carbon deposits at the interface. Step 5. Drain the engine oil immediately while everything is hot. Carbon particles and loosened varnish are suspended right now. If you let it cool, they begin settling back. Drain completely. Install a new filter. Refill with your standard engine oil. What you see in the drained fluid tells the whole story. Black particle-laden oil from an engine that had clean oil going in means the treatment found carbon your normal oil changes had been leaving behind for years. A mechanic in rural Oregon documented this on a 2009 diesel pickup with 210,000 miles running rough at idle with elevated fuel consumption. After one horticultural oil flush, idle quality returned to smooth within 2 days. Fuel consumption dropped a measured 0.4 liters per 100 kilometers over the next full tank. A follow-up borescope inspection showed visibly cleaner piston crown surfaces compared to photographs taken before the treatment. His total cost was $4.50. The dealership had quoted him $600 for a professional carbon cleaning service. This knowledge did not disappear because it stopped working. It disappeared because a $42 billion industry needed it gone before it could build itself. Horticultural oil has been conditioning metal surfaces since Roman engineers packed it into iron axle housings 2,000 years ago. Wartime mechanics reached for it when everything proprietary was out of reach and found it outperformed what they had been sold. Today, it sits on a garden store shelf 3 aisles from the $80 bottles selling you the same chemistry at 25 times the price. The automotive industry did not disprove this method. They simply made sure you never looked in the garden aisle. The oil is still there. The chemistry has not changed. Your engine is not waiting for another expensive bottle. It is waiting for you to spend $3.20 and remember what the industry spent 60 years making you forget. If this vault opened something for you, subscribe and share it. Every share is a mechanic's bill someone does not pay. The next vault opens soon. What is inside will cost them even more.